Okay, so we want to look at Unit 20 test review, and I want to get it posted on the internet for you. First thing it asks me to do is identify each compound as a strong or weak acid or base. Well, it has a hydroxide group. That tells me it's a base, and it is one of the strong bases. And you're going to have to memorize those, and those were in your notes. HCl has H in the front, tells me it's an acid. That's hydrochloric acid. Hydrochloric acid is a strong acid, and that's because it falls apart completely in water. And again, there were 3 of them in your notes that you needed to memorize, so go back to them. This is acetic acid because it starts with an H. That's a weak acid. That's vinegar. It does not ionize completely in water. H2SO4, that's another acid because it's got an H out here. It is a strong acid, so there are your 3 strong acids. Oh, no, that's 2 of them in it. Okay, so that's a strong acid. And NH3 is a base, but it is a weak base. That's ammonia. We used that in the lab when we looked at pH. Okay? Which substances in question 1 dissociate or ionize completely, meaning they fall apart completely? So we said that would be our strong acids, HCl, H2SO4, and our strong base, which is NaOH. Which substances in question 1 do not dissociate or ionize completely? So those would be our weak. So that would be vinegar, HC2H3O2, also called acetic acid because of the acetate ion, and our weak base, which is NH3. All right. Now, we're not going to worry about conjugate acids and bases because those have been dropped from the TEKS for chemistry. So that's kind of nice. So we don't have to worry about 4 or 5 or 6. All right. Everybody good so far? But we do need to concern ourselves with Table 7 because that gives us some good information. It says, fill in the table below by placing a check mark or X in the appropriate boxes. So for A and B, or for A right here, region A, we have the proton donor and the proton acceptor. We have to figure out which is the acid, which is the base. Well, a proton donor is my acid. That's the H plus that we talked about. My proton acceptor is my OH minus, which comes in a base. If it's an electron pair donor, the electrons are being donated by the base and accepted by the acid. If it yields hydrogen ions in solution, that better be my acid. If it yields hydroxide ions in solution, that better be my base. This is Arrhenius. I'm not sure I spelled it correctly. Yeah, it should have 2 R's, A-R-R. Okay, so C is Arrhenius. All right. B is not Arrhenius. B is Lewis. That's Lewis's definition of an acid. And then A, proton donor, proton acceptor, is Bronsted Lowry. And that actually has that little double dot on it, L-O-W-R-Y. Okay, so theory A, or box A, I should say, was my Bronsted Lowry. Box B, columns B, whatever you want to call them, is Lewis. And C is Arrhenius. All right. Fill out the table below. Acids have a pH that is less than 7. And an H plus concentration that is greater than 1 times 10 to the minus 7. Okay, so the OH minus concentration, I think that's where I was before I hit the pause button. Sorry, having a little brain issues here. So the OH minus concentration is going to be less than 1 times 10 to the minus 7. And the phenolphthalein will appear colorless if we are using it to indicate the presence of an acid. The blue litmus paper and acid will turn red. Remember we said blue turns red in acids. Both of them end in D. That should help you. And then red litmus paper turns blue. I'm sorry, that's a lie. Red litmus paper stays red in acid. Doesn't change color at all. Okay, then we want to go down over here to bases. Bases have a pH greater than 7. They have H plus concentration that is less than 1 times 10 to the minus 7. I'm going to check my notes and make sure I'm not lying to you. That's good. OH minus concentration is greater than 1 times 10 to the minus 7. And if I have phenolphthalein and I'm trying to see a base, it will be a pink, beautiful hot pink. Blue litmus paper will stay blue in a base, but red litmus paper in a base will turn blue. And remember, we wrote down blue in base. And both of those started with the letter B, so that should help you a little bit. Acids can be used for etching metals or glasses. Acids taste sour or tart. Sour Patch Kids, very sour, lots of acid. Bases taste bitter. Talked with my students about how one time when I was a kid, I thought that cocoa would be so good to eat because it was chocolate, and I got some cocoa out of the kitchen. Blah. It was horrible because it has a bitter taste. Bases will feel slippery. Think about soaps, bars of soap. They feel slippery. Dishwashing liquid feels slippery because they are basic. All right, let's move on. Neutralization reactions occur between acids and bases, and they make water and a salt. Now, a salt is an ionic compound, not the kind of salt you shake on your food necessarily, although it is an ionic compound. So let me show you a neutralization reaction. If I took HCl plus NaOH, which is hydrochloric acid plus sodium hydroxide, this hydrogen will hook up with the hydroxide to give you H2O or HOH. Either way you write it is water. And then Na will pair up with Cl to give you that salt that we were talking about. Here's an opportunity to do the same thing here. This H will pair up with the OH, so I'll have my HOH or my water, however you want to write it, H2O, same thing. And then this positive sodium will hook up with a negative nitrate ion, and I'll get sodium nitrate, NaNO3. HCl will hook up again. The H will go with the OH, so you have HOH, which is water, and then this potassium will attach to the chlorine because positives like negatives. This will give me H2O, still an HOH, and then I'll have CaSO4. Now, these are not balanced, so let's take a look at trying to balance them. That is 2 H's, and that is 2 H's, so that looks great. 1 O and 3 more O's is 4. 1 O and 3 more O's is 4. 1 nitrogen, 1 sodium, 1 sodium. Balanced. Looks great. 2 H's, 2 H's. 1 O, 1 O. 1 K, 1 K, 1 Cl, 1 Cl. Balanced. 2 H's and 2 more H's is 4, so I need a 2 there. 1 SO4, 1 SO4, looking good. 1 calcium, looking good. 2 oxygens for the water. 2 oxygens from the hydroxide ion, so that is balanced. All right. Going to go on down. Done all of that stuff. There we go. Want to know what the ion product constant for water is, and that is Kw. And it has a value of 1 times 10 to the minus 14th. That was right out of your notes. And your notes are always something really good to study for your multiple choice. What equations do we use to calculate pH and pOH if we're given the H3O plus concentration? That's also the H plus concentration, same thing. And the O or the OH minus. Well, pH is going to be the negative log of, and I tell my kids, the H plus concentration. And pOH is the negative log of OH minus concentration. What equations do we use to calculate H3O plus or OH minus concentrations given pH or pOH? Well, that's going to be 10 to the negative pH, and this is going to be 10 to the negative pOH. What equations do we use to calculate either of those if we're given one of them? Well, 1 times 10 to the minus 14 is going to be divided by the concentration of OH minus, and 1 times 10 to the minus 14 is going to be divided by H plus concentration. What equation do we use to convert between pH and pOH? pH added to POH must give us the lovely number 14 point, and 00 is good. All right. Show all your work for parts B, C, D on the following problems for credit. Include correct sig figs in your answer. All right. So let's take a look at that. Scoot on down here and finish these up. They're not very hard at all. Okay, a solution has a pH of 10.4. This is the only significant figure, 1 sig dig. That should say sig dig. That 10 right there is called the mantissa, and it's basically a placeholder. Okay, so if the pH is 10.4, we know it's basic. And we know that to get the POH, we're going to take 14 minus the pH of 10.4. And the POH is going to be 3.6. And determine the H3O plus concentration. Well, we said that the H3O plus is the same thing as the H plus, and it's equal to 10 to the negative pH. So that's 10 to the negative pH was 10.4. And when I did that on the calculator, I got 4 times 10 to the minus 11. Now, I only wanted one significant digit here because I only have 1 here and 1 there. So that's correct. Determine the OH minus concentration. A couple of ways I can do that. OH minus, I think the easiest way is to say that the OH minus is 10 to the negative POH. So 10 to the negative POH, POH we said was 3.6. So 10 to the negative 3.6 gives us, and when I did that, I got 2.51 times 10 to the minus 4. But I only want one significant digit, so I rounded it to 3 times 10 to the minus 4. All right, let's scoot on down and do the rest of these. We have the H3O plus concentration given to us as 4.5 times 10 to the minus 2, 2 significant digits. Is it an acid or a base? And I said it was an acid because that is greater than 1 times 10 to the minus 7. Then they asked me to find the pH, so I said, well, the pH is going to be the negative log of the H plus concentration, which is negative log of 4.5 times 10 to the minus 2. And if I did that correctly in my calculator, I got 1.35. And here are my 2 significant figures. That again, that 1 is still my placeholder. Determine the POH, so I said, well, 14 minus 1.35 gives me 12.65. And again, there are 2 significant digits. Determine the OH minus concentration. Well, the OH minus concentration is 10 to the negative POH. So 10 to the negative 12.65 is what I had. And when I did that, I got 2.2 times 10 to the minus 13 with 2 significant digits right there. This is the work I need to see on my students' paper. I don't want to just see this correct answer. They will get no credit. You got to show your work. I know you're punching it in the calculator, but since you can't staple your calculator to your test, I have to see some work. So please study and have a good weekend. Adios.